This is Unit 3, video number 6, Exceptions to Electron Configuration. We've learned the order of filling for electron configuration, 1s, 2s, 2p, 3s, 3p, 4s, 3d, on and on. Now, one of the things you want to understand is inside of the way we assign the electrons, it's not always exactly that way. There's a lot of interplay between close energy orbitals, okay? For instance, the 4s and the 3d are very close energy. The 4s is a tiny bit below under most circumstances, but there can be cases where we go to put that second electron in, it doesn't want to go there, it repels, and it's easier to slip up into the 3d. Now we're not going to spend a lot of time going through lots of exceptions, but it is good to be aware that on the periodic table, everything doesn't follow exactly the way we laid it out. It's a generalization. So, when we look at a couple of key elements, and we're really going to focus on chromium's column and then copper's column. What happens there? With chromium, we went through and did the electron configuration, noble gas configuration. Chromium is an argon core, or has an argon core, and then we would expect 4s2, 3d4. Okay? We drew out the orbital diagram of that. We're going to have a 4s. 4s has one orbital, spin up, spin down. 3d has four orbitals, spin up, spin up, spin up, spin up. And we would say that's the configuration. Well, it's not. In reality, this electron right here moves out into this outer orbital, and so chromium is actually argon 4s2 3d5. We do the electron configuration, and obviously we're going to have spin up, and we have 6 unpaired electrons, not the normal 4 we would expect from chromium. If we look at copper, we're going to have the same kind of effect. We've got argon core. Now we have 11 electrons out here, so we would expect 4s2 3d9. As you know, that would be spin up, spin down, and then in our 5 orbitals, spin up, spin up, spin up, spin up, spin up, down, 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 down. But what happens is this electron right here actually fills in here. Let me put our labels on here. And so we end up with copper being a D10 element. So copper is argon 4s1 3d10 rather than 4s2 3d9. And we can fill out the thing. So copper, silver, and gold are all going to do that. They're actually D10 elements rather than D9. There are lots of other ones. We're not going to go through and try to memorize all of them. But you want to be aware that there are exceptions to our normal. There's interplay between the orbital energies, especially this S and D, where it's very close. We're going to get a lot of this with S and P. So don't think that S electrons are jumping out and filling up P in something like fluorine. That's not happening. But when we get very close energy levels in the S and D, 4s 3d, 5s 4d, then we can have some of this interplay take place. There's also some of that interplay that's taking place regularly between the D and F as well.